Concept 6a, transformations of quadratic functions. In this unit, we're going to look at a new function called quadratic functions. Let's get down some definitions. A quadratic function is a function with a U-shaped graph called a parabola. Its parent form, or the most basic form of the equation of a quadratic function, is y equals x squared. There's a particular type of quadratic function in a certain form, and that's called vertex form. That's the first form of this equation we're going to work with. In general, it's going to look like the function equals a times x minus h to the second power plus k. And that is when a, h, and k, those values, are constants. What's nice about this form is that at a glance you can tell where the vertex is, which is either the lowest point on the parabola or the highest, the minimum or the maximum. We're going to talk about transformations of quadratic function. A transformation in general just means some kind of shift of the graph, which means a change in the equation as well. The first type of transformation we'll look at is a translation, which is a shift of the graph horizontally or vertical, but there is no change in the shape or the orientation of the parabola when we do a horizontal or a vertical translation. So let's just graph a few of these. So the parent function of this is f of x equals x squared. Again, that's the equation in its most basic form. And this is it in its vertex form, a times x minus h squared plus k. And again, that's where a, h, and k are constant numbers, and x and f of x, or x and y, are the permanent variables. So we're going to graph the parent function and then a transform function. So let's start with f of x equals x squared. I'm going to think of this in equation form as y equals x squared. I want to see what this graph is doing in the negatives at 0 and in the positives. So I'm choosing those values for my inputs. I'll square negative 2 and get 4, square negative 1 and get 1, 0, 1, 4. On your graph space, draw an xy axis that you make sure you label. Label a scale. All you need to mark is just one number on each axis to establish a scale, and then plot those points. When you draw your curve, it's a smooth U-shaped curve through those points. Go ahead and extend the ends of the curve all the way through the graph space and place an arrow on the ends just to indicate that that shape would just continue on forever. We are just giving a sampling of the inputs and outputs here. So that is the parent function. Now we'll look at this equation transformed, and you will see that the graph is going to be transformed as well. So f of x, or y, equals x minus 2 squared. If I look back at my parent function, I can see that the lowest point of that parabola is 0, 0. That is the minimum point, and that is my vertex. If I look at the equation, those values are in my h and k positions. And so when I'm graphing this new equation, I can look and I can see that this 2 is h, and my k value is 0. And so that will be my vertex. When I make a table of values to graph it, I'm going to start with the vertex, and I'm going to place it in the middle of my table. Then I want some values just to the left of that vertex. So I'm going to step in the negative direction, 1 and 0, and then 2 in the positive direction, so 3 and 4. I'll place 1. So I'll place 1 into my equation, subtract 2, which is negative 1, square it, which is 1. Do the same with 0, and I'll get 4. 3 into my equation, subtract 2, and then square that, 1 and 4. I'm going to graph this function in red. plot the points on your axes. And then draw a smooth curve. Arrows on the end of your nice U shape. And then notice how the graph shifted. So we have the graph that is the exact same size and shape, but has simply moved to the right. And so this is a horizontal translation to the right 2. So we'll keep our parent function, and now we'll graph this second transformation, f of x equals x plus 2 quantity squared. With the equation of this graph, I notice that my h value is -2, because it's the number that's being subtracted, and my k value is again 0. That's my vertex. So I'll start with that, -2, 0. And then I want to see two values to the left or in the negative direction. And I want to see what my graph is doing in the positive direction. So I'm going to place -1 in. I add 2, I get 1 and square it, and then 0. And the same for -3 and then -4. Now graph those values. And then draw your smooth U-shaped curve. Oh, kind of missed there. There we go. And then notice, compared to the parent, that graph has shifted to the left. So we've got, but again, it didn't change its size or shape. So we have a horizontal translation. I'm going to abbreviate. Translation to the left 2. One last thing I wanted to point out is if you look at the equation, look at the h value. Now just as we look at it, we see in the first one a -2, and in the second one a +2. So we could just make a generalization that when you look at an equation that's been where values have been changed from the parent, and you can recognize the h values, if the h values are subtracted, that graph is going to shift to the right from the parent, from normally where the location of the parent graph is. If the values are added, it's going to shift to the left. So just to wrap this up and get these notes down, for a horizontal translation, when you see a -h in your equation, the graph is going to shift to the right. And when you see a, that should actually read +h, the graph is going to shift to the left. And your vertex will still be at the value hk. Now let's look at two more types of transformations. So, graph the parent function. I have it graphed already, which is just y equals x squared. And now we're going to graph f of x, or y, equals x squared plus 3. And then we'll look at how the graph has shifted from the original. So let's make a table of values. But first let's just notice our h and k values. H is 0, there's nothing added or subtracted to my x. K is 3. So my vertex is 0, 3. I'm going to start with that point, place it right in the middle of my table. I want two values in the negative direction and two in the positive. If I place 1 in and square it, add 3, I'll get 4, and then 7. So let's graph that. One and 4, and then -2. Okay. So, a lot going on in this graph, but if you draw your smooth U-shaped curve, You can see that that graph has shifted up. It hasn't changed size or shape. It is simply just shifted up. So we would call that a vertical translation. Up. And notice it's up 3 units. So this is a vertical translation up 3. And now let's graph the function y equals x squared minus 3. So we'll look, our h value is 0, k is negative 3, so that is our vertex. 0, negative 3. 2 values to the left, 2 to the right. Plug in 1, square it, subtract 3, we get negative 2, and then 1, negative 2, and 1. So let's take off this graph. We still have our parent graph, and then let's graph this new one. So negative 2, 1, negative 1, negative 2, 0, negative 3. Draw a nice, smooth U-shaped curve. And you can see that this has shifted down 3. So we would call this a vertical translation down 3. Now let's just get a final, some final notes on a vertical translation. So when you see in the function plus k, the graph is going to shift up. It will not change size or shape. It will simply scoot up from where it was originally. And then when you see minus k, the graph will shift down, and the vertex will still be at hk. Now do the independent practice problems. Pause the video, and then do the problems, and then come back and restart the video to check your answers. So in the independent practice, the graph of your function g of x or y equals the quantity x plus 3 squared minus 2 should look like what you see below on my graph space. Notice that the h value here, it's what's being subtracted, so it's negative 3. The k value is negative 2. So that is going to shift the graph to the right. Actually, it's shifting it to the left. So let me change that. So to the left 3 and down 2. So the vertex will be at negative 3, negative 2, and then plotting some points, 2 in the negative direction of the x and 2 in the positive, you'll get this parabola.